Greetings, I'm Dev the developer.
And I'm Glitch, ready to turn this unstyled disaster into a sleek, mobile-optimized data fortress. Let's get to the grid.
We have the HTML skeleton from the last video. Now we're writing CSS. This time we're using CSS Grid to build the mobile layout. Before we write a single line of CSS, let's talk about why we're using grid instead of floats. In the last version of Dragon's Den, we used floats to arrange things side by side.
Floats were designed for text wrapping around images, not for page layout. We were using the wrong tool.
Right. Floats work, but they require clear fix hacks. They break out of their containers and they're hard to reason about. CSS Grid was built specifically for two-dimensional layout. Rows and columns at the same time.
With grid, you define where every element lives on the grid. No guessing how floats collapse. No clear fix, explicit control.
And here's the big payoff. Once we have the mobile layout working, switching to a tablet or desktop layout is just changing a few numbers. Grid makes responsive design dramatically simpler. Alright, let's understand what grid actually is before we use it. Picture a spreadsheet. Rows going across, columns going down. That's a grid.
A grid has tracks. Column tracks run vertically. Row tracks run horizontally. Between the tracks are cells. Each cell is one row by one column.
And between the tracks are the grid lines. If you have 10 columns, you have 11 grid lines. Line 1 on the left, line 11 on the right. Same for rows.
Grid lines are how you address elements. You say, start at line 3, end at line 7. That's 4 column tracks wide.
A grid area is any rectangular region bounded by 4 grid lines, 2 column lines and 2 row lines. When you place an element, you're telling the browser which grid area it should occupy.
There are also 2 kinds of grid. The explicit grid, you define it with grid template columns and grid template rows. The implicit grid, the browser creates extra tracks if elements overflow what you defined.
For Dragon's Den, we're using an explicit grid. We'll define exactly how many columns and rows we need and place every element by hand, so there's no surprises. Let's switch to the style sheet and get started. Every project begins with a baseline reset. Box sizing, margins, fonts. This is the foundation everything else builds on.
At charset first, then the border box rule on HTML, inherited by everything via the star selector. Then body colors, font, and margin 0.
Why border box? Because by default, padding and border are added on top of width. So a div that's 200 pixels wide with 20 pixel padding becomes 240 pixels wide. That breaks layouts constantly. Border box includes padding inside the width. It's much saner.
Border box, the width you declare is the width you get. Padding and border live inside that boundary. No math errors.
Now the grid container. This is the div with class grid wrapping everything in the HTML. Setting display grid on it turns all direct children into grid items.
Direct children only, the grid relationship is 1 level deep. A child's children are not grid items.
We'll give it 10 columns, each 10% wide, and 5 rows. The header is 150 pixels tall, the footer 100 pixels, and the 3 middle sections will just size to their content with auto.
10 columns times 10% equals 100%. Clean. And repeat 10% is shorthand for writing 10% 10 times.
Notice overflow X hidden. Percentage-based columns can accumulate tiny rounding errors in the browser. That can push the total width slightly over 100% and create an unwanted horizontal scroll bar. This prevents that.
A precaution against floating point rounding in the browser's layout engine. Defensive programming at the CSS level.
Now, let's talk about the shorthand. We'll use it over and over. Grid column and grid row. The syntax is the start line, slash, and the end line. So grid column 1/11 means start at line 1, end at line 11.
Grid line numbering provides precise coordinate-based targeting. Every element has a fixed address. No element can occupy unauthorized space. The grid does not negotiate.
Right. It's how the grid knows exactly where things go. With 10 columns, the valid column lines are 1 through 11. 11 is the far right edge. If you write 1, 10, you only get 9 columns, not the full width. It's an easy mistake.
An off by 1 error in grid placement is immediately visible as a gap. The grid does not silently absorb mistakes.
For the mobile layout, everything stacks in a single column. Every section spans the full width. Column lines 1 to 11. Each gets its own row.
Header, column 1 to 11, row 1 to 2, with background color, text color, and a bottom border for visual separation.
Ten columns, 11 lines. Row 1 to 2 means row track 1 between row lines 1 and 2. That's the 150 pixel header row that we had defined. Now, the nav bar goes in row 2, full width again. The nav styling, color, spacing, link states is all the same as before. Only the grid placement is new.
Grid column 1 to 11, grid row 2 to 3, then the navel, navly, link styles, and active state.
Notice that the nav links use display block on nav link item A. Without that, the padding only applies to the text itself, not the full width of the bar. Block makes the entire row clickable.
Hey dev, I want to push the content area down a bit from the nav. Can I just add margin top 20px to the content section instead of using grid row?
You can, but you're solving the wrong problem. Margin moves the element visually, but it doesn't change where the grid thinks it lives. If two elements end up targeting the same row, they'll overlap. Grid placement is authoritative. Margin is cosmetic.
Understood. Grid placement defines the slot. Margin adjusts within the slot. Using margin to skip rows is working around the system, not with it.
Exactly. If you want spacing between rows, use gap on the grid container or design your row sizes with that in mind. Don't fight the grid with margin. Content goes in row 3, aside in row 4, footer in row 5, all of them full width. Let's add them all at once.
All spanning column 1 to 11, rows 3, 4, and 5 respectively, with padding, border, and footer background color.
Notice article has clear both. Later we're floating images inside articles. The clear ensures each article starts below any floated content from the previous one. Without it, articles could stack awkwardly. Let's look at the preview. The header has a gap on the right side. It's not reaching all the way to the edge.
Oh, I wrote 1/10 for the header instead of 1/11. That stops at line 10, one column short of the right edge. Correcting that now.
That's the classic grid gotcha. 10 columns means the last line is 11, not 10. Line 10 is just between column 9 and column 10. Always count lines, not tracks.
N columns always produce n+1 lines. Column lines 1 through 11 for a 10-column grid. Row lines 1 through 6 for a 5-row grid.
Now, let's talk about the header banner image. The header slot is 150 pixels tall and the full page width. The banner image probably isn't that exact size. We needed to fill the slot without distortion.
Object fit. This property controls how an img element fills its box. It is to images what background size is to backgrounds.
That's a great mental model. With backgrounds, you use background size cover or contain to control how the image fills an element. With an actual IMG tag, you use object fit to do the same thing. Let's go through the 5 values. First is fill. This is the default. The image stretches to exactly fill the box. Width and height both become whatever the box is. This almost always distorts the image.
Fill disregards aspect ratio. The image is stretched to match its container exactly. Visually unreliable, not recommended for photos.
Second, contain. The image is scaled up or down to fit entirely inside the box while keeping its aspect ratio. You'll see letterboxing, empty space on the sides or top and bottom if the aspect ratios don't match.
Contain is appropriate for logos or product shots where the full image must always be visible. Safety over coverage.
Third is cover. The image is scaled so that it covers the entire box, keeping the aspect ratio. Parts of the image may be cropped. This is what we want for the banner. Fill the slot, no distortion, no letterboxing.
Cover guarantees full coverage of the container at the cost of potential cropping. Maximum visual impact, ideal for hero images and banners.
Fourth is none. The image is not resized at all. It renders its natural size. If the image is bigger than the box, it gets clipped. Useful for when you need pixel perfect rendering and you know the image size matches.
None is a precision tool. The image occupies its natural dimensions. Overflow is clipped. No scaling occurs.
Fifth, scale down. The browser picks whichever is smaller, none or contain. So if the image is smaller than the box, it stays at its natural size. If it's bigger, it shrinks to fit. It never scales up.
Scale down prevents enlargement artifacts while still ensuring oversized images fit. Conservative scaling policy.
For our banner, cover and we'll pair it with object position right so the image is cropped on narrow screens. The browser keeps the right side, which is where the interesting part of the banner lives.
Object position sets the anchor point for cropping. Default is center. We override to right. The image's right edge stays pinned. The left edge is cropped away as the viewport narrows. Object position right, the optimal focal point for maximum visual retention across all viewport configurations. Cropping coordinates are deterministic. The dragon will always be visible. This is non-negotiable.
It's just where the dragon lives in the picture. Glitch. But yes, keeping the dragon visible is non-negotiable. Let's write the image logo rule. The image needs to be 100% tall to fit its 150 pixel header slot, and we'll apply cover and position right. Height 100% makes the image fill the header height. Object fit cover fills the width without squishing it, and the object position right makes sure any cropping happens on the left side, not the right.
Without object fit, height 100% alone would squash the image. The browser would compress the width to maintain its natural proportions, which would leave empty space on either side.
Finally, the article images and sidebar photo. These work differently. We're floating them inside their parent containers, not using object fit. The text wraps around them. The key constraint is max width 40%. That lets the image be proportional to its container. On a wide screen, 40% is plenty of room. On a narrow mobile screen, 40% keeps the image from dominating the text.
Float left margin to create breathing room between the image and the text. Max width 40%, height auto to preserve aspect ratio, standard image in text protocol.
Height auto is important. Without it, if you set only max width, the browser still renders height at the image's natural height. Auto scales the height proportionally with whatever width the image ends up at.
Height auto maintains aspect ratio during width-constrained scaling. Setting a fixed height with max width would reintroduce distortion. Auto is the correct value here.
Let's look at the results. The mobile layout is clean. Header at the top, nav below it, articles in the middle, sidebar, then footer. Everything stacked in a single column. No float hacks anywhere.
All 5 grid items explicitly placed. Every element knows its row and column. The grid container holds the structure. The layout is deterministic and inspectable.
Let's recap what we did. We defined a 10-column, 5-row explicit grid on the container. We placed each section using grid column and grid row with start line and line syntax. We used object fit cover on the banner image so it fills its slot without distortion, and we floated the article images with max width to keep them proportional without overwhelming the text.
And in the next lesson, we changed two properties to produce the tablet layout: grid template columns and grid template rows. The element placement barely changes. Grid makes the restructuring trivial.
That's the power of grid. Define the structure once, adjust the tracks for each breakpoint, and the elements snap into their new position. Much cleaner than rewriting float rules for every screen size. Build the mobile grid yourself, try changing the line numbers and see how the layout snaps. Experiment with object fit values on the banner, don't just watch it, do it.